Hello everyone, welcome back to the video lecture series on computer architecture. In the today's lecture, I am going to discuss about the input-output organization subsystem and interfacing. Input-output devices that are connected to computer are called peripheral devices. So these devices are designed to read information into or out of the memory unit upon command from the CPU and considered to be the part of the computer system. So these devices are also called as the peripherals. So in the today's class, we will be discussing about the input-output organization, how the input-output components are connected in a computer and how they are organized and how the interfacing is done. These input-output devices are called as peripheral devices, or also we can call it as peripherals. Okay, so these are some of the input-output devices examples. That is, input devices are called as input peripherals, as all of us know. The examples of input peripherals like keyboard and other things, keyboard, mouse and all. Then the output peripherals, all of us know, like the printer and all. Okay, so and there are few more devices which acts as both input and output peripherals, which are used for both input operation as well as the output. Example of this input output peripheral is a touchscreen. Okay, so next we will see the interfacing of these input-output devices with the CPU. So there are basically two types of interfacing. That is a CPU interfacing and IO interfacing. So we will see it one by one. So peripherals connected to a computer needs a special communication link for interfacing with the CPU. So for interfacing of the input devices, that is peripherals, what we call it as peripherals, so we require a special communication link for connecting with the CPU. So that we call it as an interface. So in the computer system, there are special hardware components between the CPU and peripherals to control and manage the input-output transfers. So these are basically called as input-output interface units because they provide communication link between the processor bus and peripherals. So thus they provide the method of transferring the information between the internal system and the input-output devices. So first we'll see the input-output processor. So this figure shows the input-output processor architecture, how it is done. So this consists of four components, that is data bus transfer, read-write control logic, port A, port B register, control and status register. As you can see, this is the input-output processor which consists of all these things, and here the CPU and the main memory, it is interfaced with the input-output devices, and here is an input-output bus which is responsible for exchange of information between the input-output devices and the CPU. So we have an input-output processor here, and the output devices are connected. So we'll see, we'll discuss all these components of the system input-output interface one by one. Data bus transfer, which is a bidirectional bus, which is connected with the CPU, as you can see in the figure here, which is used to control the word data and the status information between the interface units and the CPU transferred through the data bus. That is, the data will be transferred to the CPU with the help of the data bus. That is the first one. Then read-write control logic, which is used for read-write control logic. This blocks generates the necessary control signals which are required for read and write operations, and all the commands from the CPU are expected are taken with the help of this read-write control logic, and it allows the status of interface unit to be transferred into the bus. As you can see, the examples of here read and write operations from the CPU to the from in the CPU. So the read operation means whatever the data which is present in the CPU will be accessed with the help of IO devices. So basically, here we have to learn that there will be two operations in the computer. That is a read operation and the write operation. That is, read operation is the data which will be accessing, which is present inside the CPU. That is, we are reading it. Whereas there is a write operation, we will be doing the write operation. That is, we will be loading some information into the computer, or will be changing the information. So that is about this one. Then port A and port B. So this is like one more part of the computer, this input output processor. So this is used to transfer the data between input output devices and the interface unit. So each port, that is here port A and B, consists of bidirectional data. That is, the data can be transferred in both the ways, and the interface unit connected directly with the input devices and the output display. So the examples of these devices are like modem, external hard drive, and magnetic disk. And one more important part of this input output processor is the control and the status register, so which is responsible for controlling all the operations in the computer. That is, to give the control signals and the status of the register. So this CPU gives the control information to the control register. So on the basis of the control information, the interface unit control input output operation between the CPU and input output devices. So thus here the control and the status registers, they are responsible for sending the control signals to start the operation and stop the operation, and the status register will display the status of the registers operation. So these are these were the components we have discussed about the input output interface, the four important components. Then we'll see the second type of input output operation, that is input output interface. So here the input output interface allows information, as you can see in the this figure here. It will allows the exchange of information between the external inputs here, external inputs, and the external inputs and the processor. That is, with the help of input output interface, that is IOI. The input output interface in a computer exists in a particular hardware component between the bus and the peripherals. As you can see here, this is a processor, and these are the devices. In between this, we will be having this interface. It is connected with the help of the three buses, that is data bus, address bus, and the control bus. As all of you know, through the data bus, the data will be transferred here, and the address bus is used to send the addresses, and the control signals will give the control signals to start the operation in a computer. So as you can see, this diagram shows the interface between the input output devices. So this figure, we can take an example of like a mouse here, which provides an input to the computer, is called as an input device, while the printer or the monitor that provides the output of the computer is called an output device. So this figure, you can take an example of from the keyboard, we give the print, and with the help of the printer, the paper, the things will be printed. So this is an example of input output interface. So this is done with the help of an input output interface. So we can see in this the model for the IO device, the model for the IO here. That is, it consists of the address line for sending the addresses, and the data lines are there, and the control lines are used to send the control signals to start the operation or to stop the operation. And in the IO model here, so we'll be having the different peripherals will be connected here with the help of all these things. So this is a circuitry which shows the input interface circuitry. So here we are using some interface connectors here. So as you can see, with the help of these interface connectors, we can connect it to the different peripheral devices. So here the protection circuitry, so it is to safeguard the module and the connected devices from the like over voltage, over current, or other potential damaging conditions required for the production for the components of like diodes, fuses, transistor voltages, and for other things. So this protection circuitry is used for this production one. Then the microcontroller or the interface IC is used here. That is the IC model, which will utilize the microcontrollers and the ICs to manage the input-output signals here and to handle the communication protocols and perform the necessary task. So we use here different types of protocols here. That is UART, then serial to parallel interface, then I2C. So these are some of the communication protocols which are used for sending the information or for communication between the input devices and the output devices. So we also have power supply circuitry in this IO model here, so which includes the components responsible for providing the power. And there is one more like the grounding scheme here, so which is used for ensuring the minimizing the noise. So use the grounding scheme. Okay, then the input output system of a computer provides an efficient mode of communication between the central system and the outside environment. So it handles all the input output operations of the computer system. And once we see the structure of the types of input output interfacing, we'll see what are the different types of modes of data transfer in the input output devices. So there are three types of data transfer techniques used in IO data transfer, that is programmed IO, interrupt initiated IO, and direct memory access. So we'll discuss these types of modes of IO data transfer one by one. In the programmed IO, as the name itself it is indicating, that is the programmed IO instructions are the result of the IO instructions written in the computer. So with the help of a program, the data will be initiated in the computer with the help of the CPU and the peripherals. So the data transfer or the task to be performed by the CPU, okay, will be done or will be initiated with the help of the program instructions. That is, transferring the data under the programming IO requires constant monitoring of the peripherals by the CPU. So in the programmed IO, basically a program will be written. So with the help of the program, the CPU will come to know what operations to be performed, and here the CPU has to keep the monitoring on this programmed IO. So with the help of that, the input-output data transfer is done. The second type of data transfer network is done with the help of interrupt initiated IO. So in the interrupt initiated IO also, there is an intervention of the CPU here. So to initiate any input output data transfer, so we'll generate an interrupt here, that is in the programmed IO method. CPU stays in the program loop while the IO unit indicates the ready for data transfer. So to overcome the disadvantages of the programmed IO, wherein the CPU intervention was required, in this we will generate an interrupt. We will generate an interrupt here. So this problem can be overcome by generating an interrupt here. So this is when the interface determines that the peripheral is ready for the data transfer and it generates the interrupt here. So in the interrupt initiated IO also, there is an intervention of CPU is there, but instead of the CPU has to wait, here an interrupt will be generated. With the help of the interrupt, the data transfer is initiated between the input output devices. So we have seen the two types of data transfer, that is programmed IO and interrupt initiated IO. So in both the techniques there is an intervention of the CPU. So to overcome the disadvantages of the first two techniques, we use a third technique that is called as direct memory access. So direct memory access, which is popularly, so this IO technique is popularly used in the computer architecture design. That is to removing the intervention of the CPU and letting the peripherals devices to manage the memory buses directly, so to improve the speed of the transfer. So this technique we call it as direct memory access. So as the name itself it is indicating direct memory access. The input and the output devices will directly be connected or will be given the access of the memory, okay, for data transfer without the intervention of the CPU here. So because the CPU has to perform some other important tasks in the computer, so we have to avoid the intervention of that. So here the input output devices will be directly given access to the memory. So the direct data transfer between the input output devices will be done with the help of a DMA controller here. So we'll see the operation of this DMA controller here. So this diagram shows the CPU, the DMA controller. So with the help of a DMA controller, we are transferring the data, the input-output data transfer uh, uh, is done in the computer by directly connecting it to the main memory here. So this consists of, so how it is done, the DMA controller will fetch an request to the processor that to avail whether the buses are free or not for read and write operations to input devices. So once the processor or the control logic, to the bus request is given to the control logic. So the control logic will check whether the buses are free or not. Once the buses are free, the grant will be given. So then the IO devices will be directly connected to the memory here, so that the data transfer happens directly without the intervention of the CPU. So here you can see address buses are there, data buses are there for transfer of address and data, and read and write operations can be done here. So this diagram during the DMA controller, so the CPU will be idle here. So the same thing is mentioned here. So here the control logic. So the request will be the DMA will request request for data transfer between the IO devices and the memory. So once the control logic says that the buses are free, so the DMA will get an acknowledgement here, so that it can the input-output devices can start communication or exchange of information between the memory and IO devices. So once it is done, so with the help of the data registers and address registers, so the data transfer happens in the computer. So this is about the direct memory access. That is, with the help of a GMA controller, what the data transfer is happening between the input devices, input-output devices, without the intervention of the CPU. That is, the input-output system of a computer provides an efficient mode of communication between the central system and the outside environment. So it handles all the input-output operations of the computer here. So we have seen the types here, and this is about the interfacing of the input-output devices. As you can see in the diagram, this is a CPU here, as a memory controller, a video controller, and the other input devices like monitor and memory here, and they are connected with the other peripherals here, like the keyboard is connected with the help of a keyboard controller, USB drive is connected with the help of USD controller, and display. So for each and every one, the controllers are there. With the help of that, the interfacing is done. So this figure shows the interfacing of these IO devices with the kernel. Inside the kernel, we are having device driver, which is responsible for driving all the devices like printers and other output devices. So inside the heart of the operating system is the kernel, which is responsible for monitoring all the things. So inside the kernel, we have a device driver, which is responsible for driving all the output devices like printers and other things, and it is interface with the user applications. So IO application interface, we have seen the same thing here. The kernel initiates all these processors here, and with the help of the IO software here. That is, the IO software contains the user level libraries and the kernel modules here. The libraries provide the interface to the user program to perform input and output. So the kernel modules provides here device drivers which are used for driving the output devices. So this is the final diagram of the input-output interfacing. That is, here there's a processor and the main memory, and here with the help of an interconnection network, so the n number of IO devices can be connected and the data transfer can be done. So this is how the interfacing is done in a typical computer here. This diagram shows the different parts of the computer hardware. So these are the references we have used for preparing this presentation. That's all in the today's presentation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.